Converting energy into continuous mechanical force usually involves an engineering trade-off. To generate substantial power, you typically need a large footprint and an array of interconnected moving parts. Traditional industrial engines reflect this need for scale. They require a sprawling production floor to house massive engine blocks and the intricate assembly of heavy components needed to keep the cycle moving. This reliance on heavy metal creates a logistical ceiling. These systems are heavy, and their sheer internal mass means they cannot spool up to peak power immediately. For applications that demand high force without the luxury of space or excess weight, this complexity acts as a physical barrier. There are environments where an engineer has to abandon the heavy power plant entirely. In these cases, the priority shifts toward immediate, high power-to-weight ratios. In off-road racing, a motorcycle must produce aggressive, instant acceleration while remaining light enough to be thrown through corners and over jumps. The same requirement applies to industrial tools. A chainsaw needs to deliver enough force to cut through dense timber, yet remain portable enough for a person to operate for hours without fatigue. To solve this, engineers moved away from traditional engine design, creating a machine that finishes its entire power cycle in half the steps. The two-stroke engine is a minimalist solution to the problem of power. It eliminates the need for complex valve trains and timing gears found in larger engines. The cylinder block itself is streamlined. It features a compact, air-cooled exterior with prominent cooling fins and a simple carburetor that feeds directly into the heart of the machine. Inside the cylinder, the engine follows a simple mandate. An entire power cycle must be completed in just 2 movements of the piston. During the upward stroke, the rising piston compresses the fuel and air mixture tightly at the top. Simultaneously, this upward motion creates a vacuum below, drawing fresh fuel into the crankcase for the next cycle. At the peak of compression, the spark plug introduces heat, causing the highly pressurized fuel vapor to ignite instantly. This single upward movement effectively handles 2 jobs. It primes the engine with new fuel below, while triggering the explosion above. That ignition causes the gases in the combustion chamber to expand violently within the confined space. This expansion forces the piston down the cylinder with extreme speed, the power stroke. This downward thrust is transferred through the connecting rod to the crankshaft, turning the energy into rotational force. As the piston reaches the bottom, it uncovers ports in the cylinder wall. Spent exhaust escapes out of one side, while fresh fuel from the crankcase is pushed into the top. In just 2 overlapping strokes, the engine has completed intake, compression, power, and exhaust without the need for additional parts. This cycle provides a significant mechanical advantage over a traditional 4-stroke engine. This comparison shows the difference in power delivery. The standard engine on the left pulses once every 2 rotations. The 2-stroke design on the right delivers a power surge on every single rotation of the crank. Delivering power on every rotation is what provides the aggressive acceleration and high output-to-weight ratio needed for agile, portable machinery. Every time the piston moves down, the engine creates power. There are no wasted cycles in between. By focusing on the simplest possible mechanics, this design achieves a level of relentless, uninterrupted power that complex machines struggle to match.